In this lesson, we're going to apply what we learned in our previous lesson over how you can prove a quadrilateral is a parallelogram into writing a flow proof. Okay, so if you remember, our key basics for writing a flow proof is we are going to first I'm going to start off with my line here showing that this is where I'm starting from, and then branching down and just copying down my givens. Okay, so I'm going to copy down my first given here, which is that HMT, that angle, is going to be congruent to angle ATM. Okay, we're going to write given because that's where that is coming from. And then I'm going to go ahead and copy down that second given here. That angle AMT is congruent to angle HTM. And since that was also given, I'm writing given as my reason. All right, from there, let's just move over and kind of highlight that into our picture to see what we're given. So we have angle HMT. Okay, so for that, I do need to kind of draw out a diagonal being formed here. And so just give me 1 second to do so. Oops. Okay, so HMT is going to be this angle here, is going to be congruent to ATM down here. And then the other given was that AMT, that angle here, is congruent to HTM. All right, so that is what we have. Now let's see what we can come up with from that. Remember, the definition of a parallelogram is that you can prove that both pairs of opposite sides are going to be parallel. And since I am given two pairs of congruent angles, let's see if we can prove those sides to be parallel to each other. So I'm going to start off by just highlighting them to see kind of where those angles are going to lie in comparison to my sides. So highlighting my first set of congruent angles, okay, I notice here that these two congruent angles share the line MT, so that is my transversal. And the other two lines that they sit on are going to be that MH and AT. So those two lines would then be proven to be parallel because of our converse of alternate interior angles, since that is what those two angles are. So that's what I'm going to write out first under this first given here that was given to me. We can use the converse of alternate, so ALT, interior angles. Okay, using that, we were able to say, remember that MH is going to be parallel to that AT. Okay, now let's see if the other pair of congruent angles helps us prove those other two sides to be parallel. So I'm going to use a different color just so that I can see this. And so when I highlight them, okay, once again, they have that transversal, that line in common, that is MT. And then I notice that the other two sides that they sit on is going to be that MA and HT. So I can say that MA is going to be parallel to HT because of the converse of alternate interior angles that I mentioned earlier. Okay, just to kind of remind you, remember when it comes to these flow proofs, there's not always going to be exactly one way you can solve this. And then this is a great example of how you could use other things. You can come up with some other stuff. Maybe you quite didn't see both pairs of opposite sides being parallel. Maybe you wanted to use your congruent triangles and come up with congruent sides from that. That is okay as well. It's just, this is how I saw it. And in my opinion, this was a quick way of doing it. And so now I have proven both pairs of my opposite sides to be parallel. So I can connect those two together. And now I can prove that MATH is a parallelogram. Okay. And so this one, you can do two things for your reason. You can write out specifically both pairs of opposite sides are going to be parallel. Or since technically that is the definition of a parallelogram, you could use that as your reason. But a lot of people just start using definition of parallelogram for everything. So I'm going to just be specific in writing out what is it exactly that I'm doing for my reason. So here I'm going to say both pairs of opposite sides parallel. So I'm going to use that double line there just to say that they are parallel to each other because that is the symbol for parallel. And then we are done. Okay, so that is it for number one. That one was a pretty quick, short one. Now let's look at number two and see what we have here. All right, so looking at number two, the first thing we are given is going to be angle HMT is congruent to angle ATM. And the second one is that S is the midpoint of MT. So starting off, I'm going to draw my line here. Okay, and then I'm going to copy down my givens. And then we can look at the picture to see what exactly it is they are giving us. Okay, and then the second one. All right, so let's look and see what exactly is this. So we have angle HMT. Okay, so we are going to need to real quickly, let's draw that diagonal here one more time. Sometimes I draw on the diagonal, sometimes I don't. You can always draw it in if you need to based off the angles that I'm giving you. All right, so HMT congruent to, we had angle ATM, so this bottom one down here. And then we also had that S is the midpoint of MT, okay? So we don't quite have that drawn, but let me go ahead and draw both diagonals here, and we can say where they intersect, that we can call that point S. All right, so we'll say that this right here is point S. So therefore, if S is the midpoint of MT, that means from that S to M and to T, we should have those two segments being congruent. So I'm going to mark that. And so that's exactly what we can come up with from that. We can say that from this given here, that using that definition of midpoint, that SM is congruent to ST. All right, so let's see what we can come up with. Well, currently, I do kind of see a lot of different triangles being formed, and I do see where we almost have two possible triangles. So just so you can see what I'm talking about, we almost are able to prove these two triangles here, this one and then this one over here, to be congruent, because I do have two congruencies on each one. And I can get the third one using my lovely vertical angles right here. So let's add that in. These two angles here are congruent. And so we can say, because of vertical angles, we can say that angle MSH is congruent to angle TSA. Okay, so now that I have three congruencies, I can say that those two triangles are congruent. And why is that helpful? Well, as I mentioned earlier, you can use a lot of congruent triangles in these types of proofs, because then you can use CPCTC to say different sides are congruent, or even different angles that you hadn't mentioned yet to be congruent. And then you can prove lines to be parallel from that. So here in this problem, we could go back into like we did in the first one. Since we had those congruent angles that were given to us, we can prove these two sides to be parallel. Okay. And then once I'm proving those, or I have proved those two triangles to be congruent, like I said I was going to do, I could then use that CPCTC to say that this side here is congruent to this side over here, which then gives me one pair of opposite sides to be both congruent and parallel. Okay, so that's what we're going to do here. I'm going to come back over here. I'm going to finish off with my proving triangles congruent. Okay, and let me look at the names. So we got, we can say triangle MSH congruent to triangle TSA. And then my reason for this is going to be, remember those pink ones, I'm going to come up with them. I haven't yet. So I'm just going to focus on the purple markings, which is going to be angle, side, angle. And now that my triangles are congruent, remember, coming up with other information to be congruent, we will use that CPCTC. And so, as I mentioned, I was going to prove that MH is congruent to AT. So now the last thing that I need to do is to prove those same sides to be parallel to each other. And that's going to come from over here, the congruent angles that was given to me. So I'm going to state that by the converse of alternate interior angles, that the segments MH and AT are going to be parallel. Okay, and now that I have proven both of those things, I can connect those two together to prove that we have MATH is a parallelogram. Okay, and remember, your reasons for this is just stating out kind of in shorter amount of words the theorem that you're using. And so in this one here, I was just proving one pair of opposite sides to be parallel and congruent. Okay, so that is it for this proof. We have now finished it. Once again, this could have been solved plenty of different ways. It's just kind of up to you and what you saw when you were working through this.